Hi, this is the Science Chef. You're welcome to the second part of a series on the correction to the 2024 WASSCE Chemistry Theory. In this video, we'll be providing the correct answers to question 2. In the last video, we provided the answers to question 1. If you are yet to watch that video, check the link in the description. Also, if you are preparing to write any O-level chemistry examination, don't hesitate to subscribe to this channel and turn on your notification bell to stay updated when we upload subsequent parts of this series. At the meantime, join us and let's ride. Now, question 2 is the beginning of section B. And in section B, you are required to answer only 3 questions, 3 out of 4 questions. So you're starting with question 2. And 2AI says, define each of the following terms. The first term is deliquescence. What is deliquescence? Deliquescence is simply a behavior of a substance, most especially salt. Yes, not necessarily salt, it can also be a base or an acid. It is a phenomenon whereby when a substance is exposed to the air, it absorbs moisture from the atmosphere and dissolves in it to form a solution. And examples of substances that exhibit deliquescence are sodium hydroxide, potassium hydroxide, magnesium chloride, calcium chloride, iron 2 chloride, etc. Now, substances that undergo deliquescence are said to be what? Deliquescent. So deliquescent are substances, while deliquescence is the phenomenon. All right, so let's write. So let's move on to the next question. This is efflorescence. Unlike deliquescence, efflorescence is said to be a phenomenon whereby a substance, when exposed to the atmosphere, loses part or all of its water of crystallization to become partly or completely what? Anhydrous, right? And examples of substances that exhibit efflorescence are mainly hydrated salts. Examples: sodium thiocarbonate 4 decahydrate, copper 2 tetraoxosulfate 6 pentahydrate, iron 2 tetraoxosulfate 6 heptahydrate, so on and so forth, right? This is a phenomenon whereby a substance loses part or all of its molecules of water of crystallization when exposed to air to become partly anhydrous or completely anhydrous. Okay, that's efflorescence. Remember, substances that undergo efflorescence are said to be what? Efflorescent. C-E-N-T. Yes. Whereas efflorescence is the phenomenon, but the substances are efflorescent. Then hygroscopy. In hygroscopy, the substances absorb moisture and become sticky, right? They form a paste. They don't dissolve in it. Just unlike deliquescence, where they dissolve to form a solution. Are we together? So that's the major difference between deliquescence and hygroscopy, right? And both deliquescent and hygroscopic substances are always used as drying agents. Okay, so let's move on to the next question. Give one example of a substance that undergoes each of the processes in 2A. Okay, deliquescent. Example of deliquescent substance is what? Sodium hydroxide. You are told to give one example, you are not told to name. So when you write the name of the formula, you'll be correct. Sodium hydroxide, potassium hydroxide. Because of their deliquescent nature, they are not suitable as primary word standards. Then you can also have calcium chloride, CaCl2, etc. Okay, so the example. So any one of this will earn your mark. While examples of efflorescent substances, you have sodium trioxocarbonate 4 decahydrate, Na2CO3.10H2O, copper 2 tetraoxosulfate 6 pentahydrate, that is CuSO4.5H2O. Then you can also add zinc tetraoxosulfate 6 heptahydrate, that is ZnSO4.7H2O. So write any one of these for each of them, you're correct. Are we together? All right, so let's move. Next question. What is meant by ionization? Ionization is an atomic property, right? Just like your electronegativity, electron affinity, atomic size, is one of those atomic properties that affect the behavior of elements on the periodic table, right? So ionization energy is simply the energy that is required to remove 1 mole of the valence electron from a gaseous atom to form a gaseous positive ion. It is always endothermic, because to remove an electron, you need to absorb energy. Energy is always absorbed, all right? So let's write. Ionization energy is the energy required to remove 1 mole of a valence electron from a gaseous atom to form a gaseous positive ion. What does that mean? It means that for the substance, for the energy change to qualify as an ionization energy, right, the electron must be removed from a gaseous atom, or probably a gaseous ion, whichever one, depends on the level of ionization energy we are talking about. If it is the first ionization energy, the electron must be removed from a gaseous atom to form a gaseous positive ion. But if it is subsequent ionization energies, right, then it can be from a gaseous positive ion to another gaseous more positive ion. So it is always what? It is always endothermic. All right. So how do we express this? Ionization energy is expressed as, generally expressed as G, gas, giving us what? X positive, right? Then plus electron. So this guy here must be what? Gaseous too. So that's first ionization energy. So the second ionization energy would be something like this. Remember, it must always be in a gaseous what? State. So that's second ionization energy. This first ionization energy, second ionization energy. So subsequently, you can also have third, fourth. As the number of electrons removed increases, the degree of ionization energy also what? Increases. All right. So let's move on to the next question. The next question says the second ionization energy value of sodium is greater than the first ionization energy. Briefly give an explanation for this observation. Okay. Now, to explain this, we have to look at the factors that affect ionization energy. What are those factors? Size of the nuclear charge, shielding effect of inner electrons on outer electrons, distance of outermost electron shell from the nucleus, otherwise called what? The atomic size or atomic radius. These factors have a part to play on the trend of ionization energy across the period or down the periodic table. But here now, we are not looking at the trend across the period nor down the group. We are comparing the first and second ionization energy of the same element, which is what? Sodium. So good. What are we going to do here? For the first ionization energy of sodium, we have this sodium gas giving us sodium ion. So this is what? First ionization energy. Okay. For the second one, we'll have sodium ion gas giving us sodium ion 2+. I want to use these equations to explain this. Plus electron, second ionization energy. All right. Now let's analyze each of them. From sodium to sodium ion, sodium is what? 2H1, right? What's the nuclear charge of sodium? Nuclear charge of sodium here is what? Plus 11. Okay, that's plus 11. That's protons and minus 11 electrons. Is it not? Good. Just follow me. While sodium ion Na plus is what? It's just 2H, right? Good. That's still what? Plus 11 protons. But how many electrons now? Minus 10 electrons. Right? Okay, then Na2+. Na2+ is what? 2, 7. That's still plus 11 protons. And how many electrons now? Minus 9 electrons. Right? Now, what do you notice here? In these 3 particles, the number of protons remains what? The same. The number of protons here represents what? The size of the nuclear charge. So you can see the size of the nuclear charge is the same for all of them, plus 11. Now let's take this plus 11, this nuclear charge, to be a magnet, right? Or the strength of a magnet as attracting 11 what? Electrons. Plus 11 attracting 11 electrons, plus 11 attracting 10 electrons, and plus 11 attracting 9 electrons. Now, based on this level of attraction between the positive nucleus and the negatively charged what? Electrons, you now want to remove an electron, right? You want to remove an electron, which is that you need to overcome that force of attraction, is it not? Between the positively charged nucleus and the negative electrons. Now, where do you think that force of attraction would be greatest? Where do you think the force of attraction would be greatest? Will it be greater in moving from sodium to sodium ion, that's Na, from Na to Na plus, or to be greater in moving from Na plus to Na2 plus? Actually, to be greater in when you move from Na plus to Na2 plus. Why? Because in moving from Na to Na plus, the first electron in this first ionization energy, this first electron here is removed from the outermost shell, which is the third shell. Are we together? Which is the third shell. So what happened here? This third shell, or this outermost electron here, suffered what we call what? A greater what? Shielding effect from inner electrons. These 10 electrons here shielded this outermost electron from getting close to the nucleus, right? Hence, the force of attraction was not so strong here, which is why it was easier to remove the first electron. Are we together? So the energy required to overcome the nuclear force of attraction to remove the first electron was not so high. Now, compared to the second ionization what? Energy. Compare that is the second electron that was removed. Now, for the second electron to be removed, you have to move to the second shell, shell number 2. Remember, the first electron was removed from shell number 3. Are we together? Now, the second electron will be removed from what? Shell number 2. And shell number 2 is closer to the nucleus than shell number 3, right? So it means that the force of attraction to the positively charged nucleus and the negative electrons is stronger at this stage than it was at this stage. So you need a greater force, you need a greater energy to overcome that nuclear force of what? Attraction. In other words, you need a greater amount of energy to overcome that nuclear force of attraction that will convert Na plus to Na2 plus. Why? Because now, unlike plus 11 protons that were attracting 11 electrons, now the same amount of protons are now attracting what? A lesser amount of what? Electrons. The strength of the magnet is the same, but the obstacle, which is the inner shell electrons, has reduced. The obstacle preventing the magnet from getting to its object of attraction has what? Reduced. Here, there were 10 electrons trying to shield this one electron away from the nucleus. But here, there are only 2 electrons now trying to shield these outermost electrons from the what? Nucleus. Are we together? Good. So, which means that the force of attraction is far greater here than it was here. So a greater amount of energy would be what required to remove the second electron in what? In sodium atom. So as the value of positive charge increases on the ion, right, the ionization energy will also what? Increase, because more energy will be required to overcome the increasing nuclear force of what? Attraction. Are we together? All right. So that is that. Now, looking at it from another angle, you are moving from a sodium atom to a sodium ion, right? For metals, the metallic atoms have greater size, atomic size, than what? Their ions, right? So, which means that the outermost electron in a metallic atom is farther from the nucleus than the outermost electron in a metallic ion, right? Which explains why in moving from Na plus to Na2 plus, the energy will be what? Very high, because the ionic size is smaller than the atomic size here. So the electrons are closer, the outer electrons are closer to the nucleus than they were in the atom. So the nuclear force of attraction on the outer electrons in this ion are far greater than it was in the atom. So that is why the energy that will be required to remove an electron from Na plus to make it Na2 plus is very what? High. So let's put it down, okay? The first electron removed from a sodium atom is removed from the third shell, or if you like call it the 3s orbital, which is farthest from the nucleus, right? And as such requires little energy to overcome the nuclear force of attraction between the positive nucleus and the negative electrons. The second electron is removed from the second shell of a sodium ion. This shell, which is closer to the nucleus than the third shell, experiences a greater nuclear force of attraction from the positive nucleus. Okay, electrons in this shell, let's put it that way, electrons in this shell, which is closer to the nucleus than the third shell, experience a greater nuclear force of attraction for the positive nucleus, thereby requiring a greater amount of energy to overcome the force of attraction. Hence, IE2 of sodium is greater than IE1 of sodium. That's the second ionization energy of sodium is greater than the first ionization energy. Simple. Okay, so that's just a brief explanation. Okay, I have to write this out so that you can easily understand what I'm trying to explain. All right, let's move on to the next question. State Charles's law. Charles's law states that the volume V of a fixed mass of gas is directly proportional to its absolute temperature, T. What's absolute temperature? Absolute temperature is simply temperature in Kelvin. In other words, Charles' law says that V is directly proportional to T. That's what Charles' law is trying to say. Now, it does not end here. There's a condition for this to happen, provided the pressure remains constant. Yes, as constant pressure. The volume of a fixed mass of gas is directly proportional to its absolute temperature, right? So V is directly proportional to T at constant P, right? Okay, sketch a graph to illustrate Charles's law. All right, so now these two graphs here represent Charles's law or illustrate Charles's law. How? This first graph here is a graph of volume against temperature in Kelvin. Volume can be in cm cube, or it can be in dm cube, whatever unit, appropriate unit that you want to use for volume, fine. But this temperature must be in Kelvin because this is absolute temperature. And the law says that volume is directly proportional to absolute temperature, which means that it starts from zero. It starts from the origin. This 0, the 0, 0 here. You need to add that 0, 0, right? This is a graph of volume against temperature. Absolute temperature is temperature in Kelvin. Now, if you don't want to represent it this way, it can be represented in terms of volume against temperature in degrees Celsius. When it is represented as volume against temperature in degrees Celsius, the graph cuts the y-axis at a point. It has a positive intercept on the y-axis, right? It does not start from the origin. And then when you extrapolate it backward, it will now meet with the x-axis, that's the temperature axis, at minus 273 degrees Celsius. And this minus 273 degrees Celsius is equivalent to 0 Kelvin, which is what you have here, equivalent to 0 Kelvin here, right? So 0 Kelvin, what is the significance of 0 Kelvin and minus 273 degrees Celsius? 0 Kelvin or minus 273 degrees Celsius is known as absolute zero. That is the temperature at which every molecular motion ceases, right? every molecular motion ceases at what? Absolute zero, at 0 Kelvin or minus 273 degrees Celsius. According to Charles's law, it is assumed that at that temperature, the volume of a gas will be equal to what? 0. In other words, an ideal gas will do what? Vanish. Charles's law, Boyle's law, and the rest are used to explain the behavior of what? Ideal gases, right? An ideal gas does not really exist. An ideal gas is only used to study how real gases ought to behave. Are we together? All right. So let's continue. So don't forget to add your 0 here, right? So let's add that. So that is it. That shows that that graph passes through the what? The origin. When drawing this, you draw this with your what? Ruler. All right. Let's move on to the next question. All right. The next question says a gas occupies 150 cm³ at 21 degrees Celsius. What would be its volume if the temperature is raised at 45 degrees Celsius and the pressure is kept constant? This is an application of the Charles's law. Okay, so what do we do here? First of, what are we given? You write out the parameters given to you. What are the parameters given to you? That's V1 is what? 150 degrees Celsius. Sorry, 150 cm³. Okay, T1 is 21 degrees Celsius. T1 is 21 degrees Celsius. Yes, T1 is 21 degrees Celsius. Okay, and to convert it to Kelvin, you add 273, right? When solving questions on gas laws, all temperatures must always be in what? Kelvin, right? So that will give us 294. So that will give us 294 Kelvin. T2 is 45 degrees Celsius plus, we can't get degrees from our keyboard, so you should just understand, just add your degrees there, right? Plus 273, that gives you 318 Kelvin, right? All right, so, and we are looking for what? V2. What do you notice here? Is there an increase in temperature or not, or a decrease in temperature? Of course, there's an increase in what? Temperature. We also expect our volume to increase. All right, so we say using what? Charles's law, or applying Charles's law. What's Charles's law? That's V1 over T1 equals to what? V2 over T2. So what do you do? Well, what you're looking for V2, so you make V2 subject of formula. You don't go and start substituting. You don't substitute straight into that first equation. You make what you're looking for subject of formula. That will be what? V1 T2, right? Divided by what? T1. Okay, you then substitute. What's your V1? V1 is 150 cm³ times 318 Kelvin divided by T1 is what? 294 Kelvin. Okay, so you evaluate this, that gives you 47700 divided by 294, which gives us what? 162.24 cm³. Of course, since the temperature increased, we'll also expect the volume to increase. So I think you can also confirm our answer should be what? Correct, right? Okay, let's V1 plus multiply. I have V1 over V1 T2, yes, over T1. T2 is 318, while T1 is 294. So, and the answer is what? Correct. All right, so let's move on to the next question. You can see, very easy, very straightforward. Let's apply space. All right, let's move on to the next question. Write chemical equations to illustrate what happens when each of the following oxides is dissolved in water. Sodium oxide. Sodium oxide is a basic oxide, it's a metallic oxide, and all metallic oxides are basic in nature. Though some of them are also what? Amphoteric, but generally they are what? Basic in nature. So when sodium oxide is added to water, it dissolves to form sodium hydroxide, which is an alkali. All right, so that would be Na2O solid plus H2O liquid gives us what? 2NaOH aqueous because it's not a solution. Please, if you are not sure of the state symbols, don't bother about it. Be silent on it. Okay, fine. Phosphorus 3 oxide, that's P2O3. I'm not sure of the state symbol of phosphorus 3 oxide, so I'll leave it. So I don't go and mislead you, right? I think it's gaseous. Can you help me find out? Plus H2O, giving me what? H3PO3, right? That is trioxophosphate 4 acid, phosphorus 3 oxide. Now, is this balanced? No. So this would be what? 3, and this would be 2, right? This can also be written as, in the dimeric form of phosphorus 3 oxide, as P4O6 plus 6H2O, giving us what? 4H3PO3. So anyone is correct. You can see I said I'm not sure of the state symbol of phosphorus 3 oxide. So it's better I leave it blank than misleading you. You can always confirm. I think it's gas. It's gaseous, but I'm not very sure. So let me leave it. Okay. If I do this, if I to write these exams and I write it this way, I will earn my marks. But they did not state that I should add state symbols. They didn't specify it. So please. Okay. Then chlorine 7 oxide. The formula for chlorine 7 oxide is what? Cl2O7. Yes, you'll be wondering how can you get chlorine 7 oxide? Chlorine 7 oxide. Oxygen is what? -2. Oxygen is -2. And chlorine, for it to be chlorine 7, means that the oxidation state of chlorine in the compound is what? 7. So if chlorine is +7 and oxygen is -2, by the time they exchange their radicals, it becomes what? Cl2O7, right? So Cl2O7 will dissolve in water to form what? HClO4. That is tetraoxochlorate 7 acid. Is it balanced? No. Chlorine here is 2, chlorine here is 1, oxygen here is, hydrogen here is 2, hydrogen here is 1, oxygen here is 8. So you multiply this by what? 2. And voila, we are good to go. Right? Then magnesium oxide. That's the last one. Magnesium oxide. Magnesium oxide, that's MgO. At least I'm sure of this. MgO is a solid, plus a basic oxide plus water. So magnesium will dissolve. Magnesium oxide will dissolve partially in water to form what? Magnesium hydroxide, a weak alkali or a weak base. All right, so that's balanced, right? Okay, so let's move on to the last question for question 2. Let's arrange the solutions in 2DI in order of increasing acidity. That's you're moving from the least acidic to the most acidic, or you're moving from the most basic to the least basic, right? Fine. So what do we have? We have sodium hydroxide, we have magnesium hydroxide, we have trioxophosphate 4. Yes. No, that's trioxophosphate 3, not 4. Sorry, that's trioxophosphate 3 acid. H3PO3 trioxophosphate 3 acid. Please correct that. H3PO3, that's trioxophosphate 3 acid. Then the last one is HClO4. Right? Now, sodium hydroxide is the most alkaline. It was the strongest alkali there. The strongest alkali there means it is the weakest acid, right? It is the least acidic. Are we together? So we're going to put this sodium hydroxide. The acidity of sodium hydroxide is less than the acidity of what? Magnesium hydroxide. Magnesium hydroxide is a weaker alkali than sodium hydroxide. That's why sodium hydroxide is a weaker acid than magnesium hydroxide. So this is weaker. Magnesium hydroxide is now weaker than what? Trioxophosphate 3 acid. This is an acid, yes. So it's definitely more acidic than these other two, right? But it is less acidic than tetraoxochlorate 7 acid. Why? Because tetraoxochlorate 7 acid is a stronger acid than H3PO4, H3PO3. HClO4 ionizes completely in water, whereas H3PO3 undergoes partial ionization. So put a sign there. So now add it in bracket here. Order of what? Order of increasing acidity. Yes, order of increasing acidity. So please, when answering questions like this, if you are not sure of the symbols of the sign, because at times students want to use less than sign, they will go and use greater than. So alternatively, you can just use your commas, right? Just write sodium hydroxide, magnesium hydroxide, H3PO3, HClO4. Then you put in bracket order of increasing acidity, or you write underneath sodium hydroxide least acidic and HClO4 most acidic. Are we together? That is it, and you'll be fine. Or you can just draw an arrow underneath it in the direction that you desire. You then write order of what? Increasing acidity. Are we together? Because it's better you do that than going to lose your mark because of the wrong signs, wrong less than or greater than signs, right? All right. So that brings us to the end of the second part of a series on the correction to the 2024 WASSCE Chemistry Theory. If you're able to learn anything from this video, don't forget to hit the like button, subscribe to the channel, and turn on the notification bell, right? To always stay updated, because very soon our next video will be on correction to question 3. In order not to lose out of that, endeavor to subscribe and turn on your notification bell, right? Also, until I come your way next time, I remain the Science Chef. Thank you, and God bless you.